Hi, hello, namaste. Welcome to PART-1 tutorial. I'm Madhvi, and today I'm here with another topic of not only just related to the IIT JEE physics, and this is about the 10th class, the most important, right? In our school, in our complete education, the 10th is very basic point. So in that about the optics, in the optics in the 10th class, we are having the first lesson is about the reflection of the light in a curved surfaces. Yes, that is a 10th class lesson. So that one it will be useful for the 10th class students who are studying now. That's the reason, in the sense of that only I'm just releasing these videos. We'll see the lesson name is a reflection of the light in a curved surfaces. In the top I wrote optics. I hope you know what is an optics, but even though I'll tell you. Yes, optics is a study of the light. Yes, and what is mean by light? Light is it is an energy which can be make a visual sensation. Yes, here, what is the light? Light is a energy. Yes, light is a energy. It is an energy, and which can make a visual sensation, which will be make an object appear for us, make an object visible for us. Visual sensation means which can be make an object visible. That is only the light. Yes, so this light is having some more properties. Light is having the many properties. In that, the first property is a reflection. Yes, in the first property is a reflection. About the reflection, the previous concepts, I think in the previous classes you have seen about the reflection and how it is reflected in a plane mirror and plane surfaces. And based on the light transferring, if the light is transferring from the medium, we are calling, suppose I will explain all those things to you now. Okay, we'll see. So a optic is a study of a light, and light is I already explained. Light is a which is the energy of an which is the energy which can make a visual sensation. That is a light energy, and optic is the study of a light, one of the branch of the physics which is studies about the light. So in this optics, we'll see the first reflection, which is already there in the previous classes, but I want to revise this again. So the reflection, before going into that, so why the reflection of concept is comes under that, under the process. We'll see. I am taking two different types of plates. Okay, this one is a glass, and another one is a wood, and another one is a some window glass is there. Window glass. Yes, these three different same length I have taken. Same length I have taken. So now I'm just sending a light through this first case. I'm taking the glass, I'm sending a light through it. So through the glass, if I observe, the light is comes out, which means if I'm there here, I can able to see the light. Yes, in the same manner, I am sending that light to this. Yes, which is wood. So here what is happening, the light is reflect back, which means it will not be comes back side, it will not be comes other side. Okay, if I am taking the window glass means like a little blur and oily, like not oily, it is like a blur and diminished, like that will be there, no? Not a transparent exactly. We cannot see through the window glass, but we can see, but not clearly. Yes, that is only now. So if you are sending a light, say the same torchlight I am taking near to the window glass, here you can see only some of the light is entering into outside, and some of the light is reflecting other side. So we can observe the three different variation in these cases. So what are those? If the objects which are allowing the light to transfer through it, to pass through it, the objects which are allowing the light to pass through it are called transparent materials. Based on the light transfer, based on the light passing, so we are dividing the object. Okay, transparent. So this wood is a opaque. Opaque is a will not allow the light, it will only make an object reflect. Next, window glass is a translucent. translucent material. Based on the light transfer, we are dividing the objects into three different types: transparent, translucent, opaque. Okay. And these are the thing. Here the total light is allowing outside. Here the sum of the light is total light is reflecting back. Here reflect, I am telling total light is moving back or bouncing back. Yes, that this phenomenon is only reflection. So we'll see all about this in the next time. So we'll see the next one, translucent. Some of the light is allowing, some of the light is reflecting. That is a translucent. We'll see. Okay, that is a translucent. So in these cases, whatever the opaque materials, so why some objects are forming shadow, or why some are not forming shadow, only this is the reason. If I am taking, this is a window, so this is a wooden plank, so I am sending the light through it. Okay, the light is not falling here, so the light will be bounce back like this, but light is not comes down. So this all side will be becomes dark. Yes, this darkness only will form like a shadow. Yes, to form a shadow or to form an image, the light will only be reason. That to be reflection will be the reason. We'll see how it will be the reason. So now in our lesson, reflection of light in a curved surface. So before knowing about the curved surface reflection, we'll see about the reflection of light in a plane mirror, which means plane surface, not plane mirror. Okay. So suppose I am taking an opaque material. This is an opaque material. Okay, opaque material I am taking. Yes. So now I am sending a single light ray, which is I am taking I. Okay. So this I is a instant ray. Instant means where I am instanting the light. Okay, I am focusing the light to a certain point. Okay, that one we are calling incident ray. Okay, the light ray is an instant ray. The light mostly we have to denote it with a ray symbol only, not with a line. Okay, ray symbol, because the light is always traveling now. So ray symbol we have to denote. So it is an instant ray. Where the instant ray is instanting, this point we are calling point of incident. What? Point of incident. Yes. So when the light ray is instanting from this point, it will be again reflect back. Why? Because it is a opaque material. Okay, it will be bounce back. This bouncing back of light we are calling reflection of the light. Yes. Here the light ray will be reflect like this. This reflected light ray we are denoting with a small r. So where the light ray is instanting, that point exactly perpendicularly. Suppose this is a plane. So for this plane, exactly perpendicular ray which we have to draw. This one we are calling normal line. Yes, normal line. So we'll say this is a normal line N. Yes. So here the angle between the normal to the incident ray. Am I clear? Not only no angle, we'll see once again. This is an incident ray where the light ray is incidenting. At the point of incident is called point of incident. From the same point of incident, it is bouncing back. This is the reflecting back. That one we are calling reflected ray. So at the point of incident, we are drawing a perpendicular line. This perpendicular line, this line should be perpendicular to the point of the incident where the surface to the surface. Yes, for that surface and for that point, it should be perpendicular. That is a normal ray. So here this normal is dividing this. Suppose it is dividing some angle. There is an angle between the I and R. Angle between this is an important angle between I and R is always 90 degrees. Both angle between the incident ray, reflected ray always should be a 90 degrees compulsory. Yes. So even this normally is dividing the 90 degrees angle to equal parts. Yes, it will be 45 45. We already know means 45 45. Yes, it is the half of the 90 is the 45. So but before that we have to know. So this normal will making some angle. This incident ray making angle with this normal is called angle of incident, angle of I. Again this incident ray making an angle with this normal is called angle of reflection angle of R. Yes, this is about the reflection of the light. So based on this, we are having, there are two laws of the reflection. Okay. Laws of reflection. The first law. First law is all this incident ray and the reflected ray and the normal. These three rays, which means I am writing I ray. I ray means what? Incident ray, reflected ray and normal line should lie on in a same plane or in a same plane. This is our first law of reflection. Next, second law of reflection. Okay, second law of reflection. Angle of incident should be equal to angle of reflection. Yes, of course, because the angle between the I and R is 90 degrees, the normal is exactly dividing the angle into two equal parts. So if it is equal, dividing two equal parts, here how much angle it is making, here also same angle it will be made. That is only our second law of reflection. Angle of I is equal to angle of R. So this one we are calling incident angle, angle of incidence or incidence angle. Incident angle is equal to reflected angle, angle of reflection. Okay. This is about the reflection and the loss of reflection. Okay, this is the basic thing which you have studied in the previous classes. But my intention is just to revise the topic to you again. This is about the reflection. Yes. So, and we'll see one more thing, one more important thing, and how the image will be formed through a plane mirror. Plane mirror is a same. It is a same like a normal plane surface only, na. So on that, how the image will be formed. To form an image, to form a shadow, only the reflection will be a reason. Yes, it is only the reason to form a shadow, and it is only the reason to form an image. Yes, we'll see in the plane mirror how the image will be formed. Okay, clear? Okay. Image formation in plane mirror. Okay. Only one case is there. I just want to explain to you. If I am taking a glass, for this glass I am coating with a silver or mercury or else aluminium. But nowadays we are using aluminium because it is cheaply available in the market for us, and silver little expensive, and mercury is also, it is a toxic and also expensive. Then in the previous ancient people, they used to coat with silver and as well as the mercury. But nowadays we are using aluminium only. So we are coating with one side is with the aluminium. So this side will act like a mirror for us now. Suppose I am keeping an object here, object dot. Okay, from this dot, one line is one incident ray. So if you observe, there is no light ray will be passes directly like this straight. It will not be passed like this, because in the textbook also they will not give like that. Why? Because for this plane mirror, there are many normal lines we can draw, but all the normal lines are like this only, straight, which means this normal line should be perpendicular to the surface. Now there are many normal lines we can draw like this. That is the reason, if a light ray, whatever the light ray passes through normal, if the light ray passes through normal, it will be reflect along with the same line. Suppose if the light ray passes through normal, it will also reflect along with the same line. There is no use with that reflected ray to form an image. Yes, so we'll see. That is the reason in the case of the image formation of a plane mirror, they will not give the light ray in a straight. Okay, so now we'll see that one light ray is incidenting on a plane mirror like that. At the point of incident, again we have to draw one normal line in one. This is I1. Again it is reflecting a light. So here angle of I and angle of R will be there. So now again one more incident ray. This is I2. Again point of the incident we are drawing into, and from this point again one more reflected ray R2, R1, R2. So here if you observe, so where the image is forming, image formation actually where it should be happen, why the image is will be formed at a certain point. Yes, that is our doubt. So if you see this type of the phenomena will be happening in any kind of aspects. If you are standing in front of a mirror, there are many light rays are falling on you and again reflect into the mirror. Because of this reflection, our each and every point, at this point will be form an image, and this point, each and every point of this object will be form an image. A point to point it will be form an image. So here I am simply taking a single normal point. Yes. So here after that what will be happen, here the reflected rays are there now. These reflected rays should intersect with each other. So where the reflected rays are intersecting, that point is our image formation point of image. Yes, that is our image formation point. But here if you see, the reflected rays are not intersecting, which means through a plane mirror there will be no image. No, we can see our image in the plane mirror, right? Yes, we can see. So now what we should have to do, just we have to take a scale and extend backwards. Exactly, this is also extend backwards, same as it is here. It is forming a this dot as a image here. So now see, here image is forming, but image is not forming by intersection of a real reflected rays, right? It is not forming by the intersection of a real reflected rays, but it is forming by the intersection of extended reflected rays, not real but extended reflected rays. That is the reason here this image will be formed, but this is a not a real image. The properties of a image by a plane mirror, the properties of image is a virtual. This is not a real image. In our home we are every day we are looking our face in the plane mirror, na? That is not actually a real image, that is a virtual image. Wherever the virtual image, it will be erect only. And one more thing, by the plane mirror what will be happen, the light rays will not be fall. If the light ray falling on me, it will not go straightly to the plane mirror, because I already said you, if the light ray passing through a normal line, it will be reflect along with the same line, so there is no use. If the light ray falling on me on the vertically and slanted way like this, if it is falling on me like this, one light ray is falling on my hand, again it is reflecting to this side, which means left side is reflecting to right. One light ray is incidenting on me to the right side, it will be reflecting to another side, which means here what is happening, the left and right light sides are changing. Yes, that the changing of the left and right sides, we are calling that a lateral inversion, which means laterally. Suppose if you are taking two triangles, this side is a lateral side, this side is a lateral side. If these two sides are interchanging, that one we are calling lateral inversion. So through the plane mirror, lateral inversion can be takes place. Through the plane mirror, lateral inversion can be takes place. It is a virtual image, erect and lateral inversion will be takes place in the case of the plane mirror while it's forming an image. Yes, this is the reflection and image formation in a plane mirror. Okay, the reflection in a plane mirror we have seen as of now. So let's coming to the topic, reflection of a light in a curved surfaces. We'll see the curved surfaces. Am I right? Yes. Suppose if I am taking a sphere, okay, if I am taking a sphere for this circle, it is having a one center of curvature, we already know. It is having the radius of curvature for all points, from here to all the points, the radius of curvature will be same. So if I am taking this side, yes, if I am taking, this is completely a glass circle, suppose we are taking only half part of this one, Okay, we are taking only half part, half curved part. Okay, for this glass. So if you are taking a straight plain mirror, if you are coating this side, if you are coating this side if you are keeping an object, it will be form same image. Suppose if you are coating this side we are keeping an object, it will also form a same image. But in the case of this curved surfaces, this is a curved one. Na? If you are coating back side, this bulged side, this hollow side. If you are cutting a ball also, it will form this type of things, right? This is a hollow, this is the bulge. Yes, this is a hollow side, and this is the bulged side. Yes, so if you are coating to the hollow side, this bulged side is act like a mirror. So if you are keeping an object here, okay, observe. And next, in the next case, next case suppose if you are coating outside, okay, if you are coating outside, keep an object, same object here, this side is act like a mirror. If you are coating other side is act like a mirror, na? Keep a same object here, it will also be form an image. But if you observe the image properly, here the same object we are keeping, but the way it is forming an image, here it is different, here it is different, but the same one we are taking. But if you are coating this side, hollow side, it will be form different type of image. It will be, if you are coating this side, but this hollow side will be form different type of image. So that is only based on these two. The curved surface mirrors we are dividing into two different types. So this side is a convex, this side is a concave side, this is the convex surface. If you are coating the concave surface, the convex surface is act like a mirror. That is the reason this one is a convex mirror. Yes, next, this is the concave surface side, this is the convex surface side. We are coating to the convex surface side. Concave surface will be act like a mirror. That is the reason we are calling this the concave mirror. Okay, in a concave mirror or convex mirror, the common points are there. Center of curvature is common because we have taken, this is a center of curvature. What is the center of curvature means? It is a center of a sphere from where the spherical mirror we have taken, that one center of a curvature. And the distance between center of curvature to here, compulsory, you already know, that is the radius of curvature r. Yes, radius. Next, the middle point of the mirror we are calling pole. For this also pole, the middle point of the mirror, for the mirror, the middle point we are calling pole. So the length between the pole to center of curvature is the radius of curvature, and exactly the midpoint between the pole and center of curvature we are calling, what we are calling? We are calling it is a focus point. Am I clear? We are calling it is a focus point or focal length. Okay, C is a center of curvature and P is a pole and F is a focus or a principal focus or focal point. We can also call focal point. Okay, and the line, the horizontal line which is passes through principal axis, focus and center of curvature, we are calling the horizontal line which is passes through the center of curvature, focus and pole, we are calling principal axis. What is meant by PA? Principal axis. Okay, PA. So for this also common, PA, principal axis. Okay, these are the parts of a spherical mirror. If you are taking, these are the parts of a spherical mirror. If it is a convex or concave, both are common, same only, but the side of the mirror which will be different. Okay, here it is a bulged side and that is a convex mirror. Hollow side act like a mirror, that is a concave mirror. Okay, these are the two different types of a spherical mirrors or curved surfaces mirrors. So we'll see and how the light it will be reflected. Those will be reflect the light same as the plane mirrors and same as opaque, or in a different way. We'll see how, in which case it will be formed in all cases. If you are instanting here, instanting here, instanting here, whether those will be reflecting the light in the same manner or in another manner, we'll see in the next upcoming videos. Until that time, please watch the videos, and also like the video and share the video which is useful for to your friends. And in this first class I'm just started with the basics only, and the next class onwards I will be enter into the topic. Okay, so we'll see. Thanks for watching the video, and if you have any comments, if you have any doubts, you have to comment below, and like the video and subscribe the channel. And thank you for the watching. Okay, thank you.